The Europa Clipper spacecraft behind me is in a chamber that recreates outer space. We're going to show you how it was put to the test before making the journey to Jupiter's icy moon. Built in 1961, this 85-foot tall, 25-foot wide space simulator has tested deep space missions like Voyager and the Perseverance Mars rover. Tony's team had to get it ready for Europa Clipper.
The Europa Clipper spacecraft had to be transported from a different building on lab to this building. This is a very, very narrow facility in a very small space to get a very large spacecraft into the chamber.
3, 2, 1, all stop!
We've been planning this for almost a year or more to get all of the moves choreographed down to where people were going to stand to get the spacecraft from this hallway in through this chamber. It weighs 6,000 pounds. When the spacecraft is lifted off of its fixture, it is free hanging from the cranes. And the only control we have of the spacecraft is from taglines. A tagline is just a rope like you would see in the Macy's Day Parade as they hold the floats. The tagline operators are our only way of managing the spacecraft's weight as we progress it on the crane into the chamber. It's a very large team that works on this. It really shows how well we've bonded together to be able to do something like this over just a few days. Once the door is closed, there are pumps in the room that pull out all the air from this chamber. That gives us the vacuum we need to replicate space. The walls, as you can see, are all black and there are pipes running down the walls. All of those pipes will get flooded with liquid nitrogen, which cools the space down to about minus 130 degrees C. The chamber takes up to 3 to 4 trucks of liquid nitrogen every day to make sure this chamber stays as cold as we need it for the duration of the test.
Europa Clipper will be in the chamber for over 2 weeks.
We will go through phases of testing. We will turn on our solar simulator at different levels of energy to replicate being close to the sun, further out from the sun, and to replicate being out by Jupiter. 3 floors below us are 37 lamps that illuminate up through a beam, through the wall of the chamber, up to a 25-foot mirror up in the ceiling of the chamber that collimates the beam of light down back onto the spacecraft. That light replicates the sun and the solar energy coming from the sun when we're on orbit. Once we're in environments for the test, the systems team will power on the vehicle and test out different instruments to make sure they're operating correctly. By the end of this test, we hope that the spacecraft is ready for its journey to Jupiter and it can survive the temperatures on its way out to Jupiter and Europa. I've been on this a very long time, many years spent on this spacecraft, so I'll be very happy, very excited, very sad to see it go, but we want to make sure it's successful when it gets to Jupiter, and we want to make sure it can do its job correctly.